Hi everyone and welcome back. Today I will be solving a bunch of questions about exponential graphs. I hope you guys get introduced to the basic concepts of what they are and how you can solve some of the basic questions. So, what is an exponential function anyway? An exponential function is any function that's in the form of y is equal to a times b to the power of x, where a and b are basically numbers, and b is definitely bigger than 0, and b cannot be equal to 1. Now let's go ahead and take a look at one of the examples for a exponential function and how you can graph it. Let's say, for example, they give you something like y is equal to 2 to the power of x. The first step in graphing any exponential function is to make a table. All right, you make a table. So you just make a table like this. You got the x and y value. All right. After that, choose 2 points before 0 and 2 points after 0. For example, you can choose 2 points after 0 would be, so you put 0, 1, and 2, and then 2 points before 0 would be -1 and -2. And if you guys are familiar with what that means when the x's are given, you just basically have to plug them back inside your y or your function. So you're going to get, for this one, you're going to get 2 to the power of -2, which basically is 1 over 2 to the power of 2, which is 1 over 4, which is roughly, actually no, exactly like 0.25. And then you get 2 to the power of -1, which is 1 over 2 to the power of 1, which is 1 over 2. So that's going to be 0.5. So this is 0.5. Now, one of the main things that people get confused about is this part. They forget the fact that any number essentially being raised to a negative power can be written down as a reciprocal, but with a positive power. So, for example, 2 to the power of -2 can be written down as essentially 2 to the power of -2 can be written down as 1 over 2 to the power of 2, which is 1 over 4, right? Or 3 to the power of -4 can be written down as 1 over 3, but this time to the power of +4. So when you make it a reciprocal, the power can be written down as a positive. Of course, you can just use the notation of -1 on your calculator, or just raise it to the power of whatever the exponent is to find the value. But this was just some explanation for you guys to understand it better. Now, the next one is actually 2 to the power of 0. How do we deal with this one? Well, anything raised to the power of 0 is actually 1, right? So 2 to the power of 0 is also going to be 1. The next one, you got 2 to the power of 1, that's going to be 2. So you write, this is 1, 2, and then 2 to the power of 4, which is 4. So, all right, so far simple. The next step is just to graph your values. Just plot them on the graph. So you got the step 2. Just plot your points. You got the y-axis and the x-axis. Make sure you space out your y values correctly so that your graph looks a bit nicer. So over here, I'm going to have 0. Let's say this is 0.25, which is half of 0.5. So this is going to be 0.5. And then this is 1. I got 2, 3, and 4 right there. And then for the x values, it starts with -2, -1, 0, 1, and 2. 2 right there. All right, so the first point is -2 and 0.25, which is right here. Second point is -1 and 0.5, which is right here. So this is -2 and 0.25. The other point is -1 and 0.5, this one. And then I have 0 and 1, which is right here. That's my y-intercept. Then I have 1 and 2, which is right around here. So that's 1 and 2. And then after that, I have 2 and 4, which is here. So this is 2 and 4. The third and final step is to go ahead and connect all of these points, and you have yourself a graph. Now notice that the graph is going upwards. So basically this is called a growth graph, right? Why? Because the value of whatever function you started with is now starting to increase. The y values, the output values are starting to increase. As you can see, initially with the negative values, you had negative 0.25. But as you went ahead and used positive x's, the values start to increase to 4. So this is known as a growth graph because from left to right, the graph goes up. Now, this could be representing, for example, the number of bacteria in a petri dish that are growing, or for example, the amount of money that you're profiting from a compound interest or something like that. Regardless, it's just showing the growth of a variable. Now, if the graph is going downwards, if it's the opposite of this, it's like this is going down, then this is showing you the decay of something, right? That means that thing is basically being decreased. It's basically the value of whatever you started with is going down now. And in that scenario, you actually have something like this. For example, the graph, if I'm just saying for an example, just anything that has a negative a, this coefficient a, if that one is negative, then your graph will be going down, and it's known as a decay graph. So if a is negative in this one, then you will have a decay graph. But if the coefficient of b over here, for example, is positive, as you can see, is positive, like positive 2, then your graph will be going upwards from left to right. Thank you for watching, and stay tuned.